So simple rule is that if the arrow goes in the clockwise direction, then we will assign it R, and if it goes in the anti-clockwise direction or counterclockwise direction, then we will assign it S. So this is a general example how to assign the priority of S and R. So for example, this is a chiral carbon. It has 4 different groups attached, 1, 2, 3, and this is whole group is the 4. So how we will assign the first priority number? We will assign the first priority number to that atom which has the highest atomic number. Nitrogen has the 7, carbon has the 6, hydrogen has the 1. So this would be the first. But how we will assign the second or third priority group if the carbon is attached to the same two atoms, like this is also a carbon, this is also a carbon. Then we will see the secondary attachments. So this carbon has the secondary attachments of oxygen atom which has the highest atomic number, but this carbon has the secondary attachment of hydrogen which has the lowest atomic number than these of the secondary attachments. So we will assign the second to this group, third to this group, and hydrogen would be the lowest atomic number, so this would be the 4. So first step is to assign the numbering, and then we will draw the arrow like 1. This would be on the dash, so it would be backward. This is in the plane. So 1, 2, 3, and this is at the, if we imagine a molecule in 3 dimension, like it is on the wedge, it would be in the back. It would be in the back. If we will imagine it in our mind that it is a 3D molecule, so that atom which is on the wedge is on the back side of the molecule. So this would be the counterclockwise, and we will assign this is an S configuration. So clockwise is R, anti-clockwise is S. This is another example. Like this is the carbon. We will assign the first priority group to the oxygen because it has the highest molecular formula, highest atomic number, highest molecular formula. And the second or third priority group we will assign to that this is also carbon, this is also carbon, but it has the secondary attachment of more number of atoms of carbon and hydrogen. It has less. This is propyl, this is ethyl, so this is 2, 3, and 4. And then the second step is that we will draw an arrow like 1, 2, 3, and this is the lowest priority group. So we will rotate the arrow, so this would be the clockwise direction, and we can assign it the R configuration. So there is another hint. If the lowest priority atom, usually hydrogen, is oriented towards you, like it is on the wedge, you don't need to turn the structure around. You can leave it as it is with the hydrogen toward you and apply the RS rule backward. So we will understand this from this example. This is the carbon. Okay, the first priority group is this one. And what is the rule about the double bond? That this carbon is attached further to a carbon, and this carbon is also attached further to a carbon. So it has the highest molecular formula, so we will assign it 1, and we will assign it this 2, this is 3rd, and this is 4th. So we will rotate the molecule. This would be in the counterclockwise direction. So about this point, for example, suppose that this hydrogen is not on the dash, it would be on the wedge like this. So we will assign the numbering, just normally draw the arrow, and what would be the configuration, we will just reverse it. Like if it comes to be the R, then we will say it would be S. If it comes to the S, then we will say it would be R. So this is just a common hint. So this is the problem, that draw the enantiomer of 1,3-dibromobutane and label the R and S, making a model to particularly help for this type of problem. So this is the solution, that the third carbon atom in the 1,2-dibromobutane is asymmetric. So we will first have to figure it out that which carbon is asymmetric or which carbon is chiral or achiral. So first of all, see this carbon, this chiral carbon. It has 2 hydrogen atoms attached to it, so it has 2 similar groups, so it can't be a chiral molecule. Same is the case with that. So we will see this chiral, this carbon center. So it has 1 group is attached bromine, second is this, third is this, and fourth is the hydrogen atom. Same is the case with that. So how we will draw its enantiomers? Simply, which is the highest priority group, bromine, attach it on the lowest wedge. Like the wedge is indicating the backward direction of the atom. So just